Welcome to SciSpectrum Lab Essentials, your source for equipment, instrument, and consumables.
Okay, so let's just jump right in with a problem I know so many people have run into. Why is it that labs are constantly struggling with unstable or just plain unreliable humidity readings, even when they're using, modern digital instruments? Actually, before we get into the why, maybe we should just back up for a second and cover the what. For anyone out there who might need a quick refresher, what exactly is a hygrometer and why is it so fundamental in a lab setting?
Absolutely. So a hygrometer has one very specific job: to measure the moisture content, the humidity in the atmosphere. And, while that sounds pretty simple, its role in a lab is just absolutely critical.
And that's because if you have uncontrolled humidity, it can pretty much compromise every single aspect of your work. If you look at the slide here, you can see it's essential for keeping your sample stable, for maintaining the accuracy of your other instruments, protecting reagents and storage, and of course for validating controlled environments. Without that tight control, your data integrity is seriously at risk.
Okay, so it's clearly a big deal. But how does it actually work? I mean, what's happening inside that little box to give us a reading?
The mechanism is actually pretty neat. At its core, there's a sensor. It's either a capacitive or resistive that's specifically designed to react to airborne moisture. So as water vapor lands on it, the sensor's electrical properties start to change. The instrument's brain then measures that change and converts it into a percentage of relative humidity, or %RH, and that's the number you see on the screen.
That makes sense. So with that kind of sensitivity, where are we most likely to run into these instruments in a scientific setting? What are the key applications?
Oh, they're indispensable pretty much anywhere humidity is a critical factor. So we're talking pharmaceutical stability chambers, incubators for cell cultures, clean rooms, food testing labs, and of course any area where you're storing sensitive chemicals and samples. In all of those places, getting a precise humidity reading is just non-negotiable.
It's really interesting how something so crucial can also be so easy to get wrong. Let's move on to some of those common pitfalls and, more importantly, the solutions for getting those spot-on readings.
Okay, let's get specific then. What are the most common mistakes that lead directly to those wonky humidity readings we were talking about at the start?
Well, there are a few usual suspects. A huge one is just not letting the device acclimate before you take a reading. If you move it from a cold room to a warm one, it needs time to stabilize. Another is exposure. Any kind of contamination or condensation on that sensor will throw the reading way off. The sensors can also get damaged from being exposed to really high humidity for too long. And finally, improper placement is a massive factor. If you stick it right next to a vent, a door, or a heat source, you're just getting a reading of that little microenvironment, not the whole room.
Right. So knowing all those problems, how can labs get ahead of this? What are the best practices to make sure their hygrometers are performing as accurately as possible?
These solutions really just directly counter those problems. First, regular calibration against a traceable standard. That's a must, no exceptions. Second, keep that sensor clean and protected. Third, placement is everything. Put the device at the right height, away from any direct airflow or heat. And finally, a great habit to get into is doing periodic cross-checks with a trusted reference instrument, just to verify your main device is still on track. This really highlights how important it is to not just use the instrument, but to truly understand it. So let's talk about that long-term picture, maintenance and the sensor's lifespan.
Which leads to a really practical question that every lab manager faces. How do you know when it's time to stop trying to calibrate and just replace the sensor? What are the signs that it's reached the end of its life?
There are several really clear signs to look for. A healthy sensor will respond quickly to changes in humidity. A failing one will be really sluggish. You might also see the values start to drift consistently over time, or maybe the readings just become erratic and jump all over the place. In some cases, you might even see visible corrosion on the sensor itself. But really, the ultimate sign is when the instrument just can't pass calibration anymore. At that point, it's not a reliable tool, and that sensor has to be replaced.
Wow, this has been incredibly helpful. As we start to wrap up, what's the one single most important takeaway people should remember from all this? The key message, really, is that stable humidity is absolutely essential for reliable lab operations. A well-maintained hygrometer is the tool that makes sure your samples, your instruments, and your entire controlled environment stay exactly where they need to be. It's truly a cornerstone of data integrity.
That's a perfect summary, and it leaves all of us with one final question to take back to our own labs. Is your data truly reliable if you don't have perfect humidity control? Thanks for joining us for this explainer,